Hi, welcome back to my YouTube channel. So let us see question number 16 from 2019. It says, find the area of the smaller portion enclosed by the curves x square plus y square equal to 9 and y square equal to 8x. So in the solution, let us, first of all, we have the curves are x square plus y square equal to 9. Let us give this equation number 1 and y square equal to 8x. This is my curve number 2. So let us draw this figure first of all. My curve number 1 is nothing but if I plot this in xy plane, if this is my x and this is my y axis, so my equation number 1 is nothing but the equation of a circle with center at origin and radius 3. That means if I have a circle like this with center at origin and radius, this is 3. So this is my curve number 1. Now curve number 2 is nothing but a parabola y square equal to 8x. So this will be of the type parabola passing through origin, something like this. So this is my curve number 2 and this is my curve number 1. Now if we look at this figure, we see that this curve intersect at this point and the area enclosed by these two curves are divided into two parts. This portion and another one is the remaining one. Here the question wants the smaller portion, that is the question wants this region. So let us give it a name. Say this is my A, this is my C, this is my say A dash. Now it is clear that the coordinates of C is 3, 0. Now in order to find the area of the smaller region, let us first find this point of intersection of these two curves. So let us solve 1 and 2. From 1 and 2, if I solve it, we get, so if I put value of 2 in 1, then I will get this as x square plus 8x equal to 9, which is nothing but x square plus 8x minus 9 is equal to 0. So if I factorize it, I will get this as x plus 9 x minus 1 equal to 0. So finally I will get x equal to minus 9 and 1. If I put this value of x in equation number 2, what I will get? Therefore when x is equal to 1, then from number 2 I'll get my y square is equal to 8. This implies my y will be equal to plus minus root over 8, that is plus minus 2 root 2. Again, when x is equal to minus 9, my y square will be equal to minus 72 from number 2, equation number 2. So this will imply that y is an imaginary number. So this case is not possible. Why? Because we are dealing with only real numbers, but if x is equal to minus 9, then I get that y is imaginary number. So I will consider only this first case. Therefore point of intersection of curves 1 and 2 are A. Okay, A is my this 1 2 root 2 and a dash 1 minus 2 root 2. So in the figure I can say that this coordinates is 1 comma 2 root 2 and a dash is 1 comma minus 2 root 2. I want to find the area, this dotted region. So what I will do, let us draw a line here and divide this figure. Draw one line here. If I draw one line here, then this will be my 1 here, this point. So let us name it, say capital D. Capital D. This is 1. Therefore, my required area, I can write this is nothing but area of the enclosed region. My enclosed region is, I can say this as OAC A dash O. So this will be OAC A dash O. This one I can write. Now if I look at the figure properly, this whole dotted region, this is symmetrical about x-axis. That means the region above x-axis is equal to the region below x-axis. So instead of finding the whole area, I can find only the region above x-axis and I can multiply this by 2. That means I can write here, it says 2 times area of the region. So I can write area of the region, this one, ODCAO. So area of the region ODCAO. Now this ODCAO, this region here, again I can divide this into 2 parts. So how can I write? I can write this as 2 times area of OADO plus area of CADC. What I've done, this is OADO, this one, and next I have written CADC. So if I look at this figure, for this particular region, my x varies from 0 to 1. This is my 1, 0 to 1. And for the remaining portion, my x varies from 1 to 3. And if you look carefully, in this particular region, my curve, this is my curve number 2. This is my curve number 2. And for this region, this is my curve number 1. So what can I say from here? This will be 2 times area of OADO. This will be integration 0 to 1, x varies from 0 to 1 y dx, plus x varies from 1 to 3 y dx. And for this region, my curve is nothing but the parabola. Obviously, for the first region, my curve is my parabola, and for the second region, from 1 to 3, my curve is the circle. So here I can write in place of y, since I can write, since y square equal to 8x, so I will write this as 2 root 2x whole root dx plus integration 1 to 3 root over 9 minus x square dx. So the first portion, this will be 4, 2 will come out, and this is root over x, so this will be x to the power 3 by 2 integration 0 to 1 plus 2 times, we know integration root over 3 square minus x square. This one I can write as x half x root over 9 minus x square plus 3 square by 2, that is 9 by 2 sine inverse x by 3 1 2 3. If I put 1 x equal to 1, then this will be 1. If I put x equal to 0, this will be 0, so I'll get only 4 root 2 1, that means this will be 2 by 3 plus, so from here this 2 gets cancelled, so I will have only, so if I take 3 here, this first part will be 0, so I will get only second part, that is sine inverse 1 minus, this will be 1 root over 8 plus 9 sine inverse 1 by 3. This we will get as 8 root 2 by 3 plus 9 pi by 2 minus of root 8, I can write this as 2 root 2 minus 9 sine inverse 1 by 3. This one, if I simplify this, I will get 2 root 2 by 3 plus 9 pi by 2 minus 9 sine inverse 1 by 3, which is my required area of the smaller portion enclosed between the two curves. Thanks for watching.